Okay, I'm gonna warn you guys. There's not a lot of There's not a lot of like examples. So this is gonna have to be a section that if you don't get it, you're gonna need to either reach out or kind of rewind back, because all of these problems kind of are the same. They follow the same pattern, the path, whatever. So today we're actually not going to talk about decay yet. That's Monday. We're going to talk about exponential growth. So sadly, we're seeing exponential growth happen right now with COVID numbers. Exponential growth is when you have a flattened curve and then it goes up, which, as many of you know, that's what's happening right now. So how we're going to talk about exponential growth, though, is when your data, or when a graph or a set of data grows from left to right by a rate that is greater than 1. So it's basically when your b is greater than 1. That is when you have exponential growth. So things that like usually grow exponentially, housing values. I'm trying to now I'm drawing a complete blank, but usually money. In some way, if you invest your money, you would hope that it would grow exponentially, because then you would get more money faster. So with exponential growth, you are going to have to write an exponential equation, and we are going to have to take into account the growth factor. So they're going to tell you a percent, and everything will be given to you as a percent. It's growing at a rate of 5% or 10% or something. So we have to take that 5% or that 10% and help to create this thing, or write in your equation the growth factor. So all of your exponential equations are y equals a times b to the x. Well, this b is where your growth factor is going to come in. And this b value is going to be 1 plus whatever that rate is. So 5%, 10%, something like that. The issue, though, comes, and I hope that if you get confused, rewind this back, is that this rate is always going to be given to you as a percent. So it's going to be given to you as a percent, and you have to change it to a decimal. And when you take a percent and change it to a decimal, that means that you move the decimal 2 places to the left. So like, for instance, if I gave you 5%, I'll go with the hard one. You would take the 5, because there's no decimal written here, that means the decimal's here, you would move it 1, 2, so 5% as a decimal would be 0.05. So those are just some things to keep in mind. You're definitely going to need to know how to move a decimal. So let's take a look at the only exponential growth example that I have for you. And all of your exponential growth equations and your problems are all going to mimic this, and you just have to make sure you write the equation correctly, and then you're going to be able to plug into Desmos. So you will need Desmos today. It's going to be your BFF, so I've got mine ready to go. It says the population of Hillville grows at an annual rate of 15%. And they want to know, what will the estimated population be in 5 years? So we need to write our exponential equation first, and then we can plug a 5 into it. So the exponential equation are always y equals a times b to the x. A times b to the x. A is your initial value. So we're starting out with 5,000 people. And then b is going to be 1 plus the rate. So our b is going to be 1 plus 15%. But remember that 15%, we have to move the decimal 2 places to the left. So it's going to be 1 plus 0.15. So the b that we are going to use is going to be 1.15 to the x power. So that's how you plug in to plug it into a formula or an equation. So again, I took the 15%, moved the decimal 2 places to the left, and it became 0.15, and you always do 1 plus 0.15. So 1.15. What they want to know, though, is what will the population be after 5 years? So we're going to take, instead of x, we're going to plug in a 5. So in Desmos, we're going to do 5,000, parentheses, 1.15, and my parentheses, and then this a to the b, and then instead of x, we're going to plug in a 5. And there's your answer. And there are 1,0,056 point, and then we're going to do 1 decimal place, even though you can't have a decimal place of people, but we're going to do it. So in 5 years, if the population is growing at 15%, we'll have doubled. 10,056-ish people will be in Hillville. So people. So you're going to be setting up the equation the same exact way every single time. You're going to be plugging in the initial amount and then do 1 plus the percent, and then you're going to be raising it to a power. So just please make sure, if that was confusing as you're working through your problems today, go back and take a look at this example. The other things that you're going to see, sorry, excuse me. Now we're going to talk about some money here. So when you invest money into a bank, they usually tell you what your interest rate is. Like, I put my money in a credit union, and I'm not going to lie, I don't really even know what the interest rate is because my money's been in there for so long, like probably since I was like 7 years old, I think. But my bank gives me an interest every month. My credit union does. They like shared interest, and it's like pennies, but they give me money. So when you are investing money, you want your money to compound multiple times a year so that you can make more money. So this is, we're going to be doing compound interest. So compound interest is when your interest is continually, it's like you're continually making money on the actual amount of money in the account, not on just what you initially put in, but now on the actual money that's now, it's kind of hard to explain, but you're only going to have to do compound interest. So this is the formula for it. It looks a little scary, I'm not going to lie, but I'm going to show you how Desmos will be your BFF for this. So this is the amount that you're going to actually end up paying out, or that they're going to pay out to you. P is going to be your initial amount. It says principal amount. This is going to be like the amount, the initial amount, or the initial deposit, like how much money you deposit in. And then R is going to be your rate. And remember, you need to change that into a decimal. N is the number of times that it's compounded, and it's the number of times per year. And this is where you have to really pay attention to the directions. If it says annually, you're going to plug in a 1. If it says quarterly, did I even spell that right? I don't think I did. But if it says quarterly, bear with me. If it says quarterly, that's going to be 4. If it says semi-annually, that means it does it 2 times. And I think those are really your only options. Annually, quarterly, semi-annually. I think that's really all that you would end up doing in terms of compounding. But they could do it monthly. I lied. They could do it monthly. And if they do it monthly, that would be a 12. So here are some things to keep in mind as you work on your assignment today. I think that you will end up using all of them. And then T is the number of time in years. So the hardest part, the part that's going to take the longest for this, is actually plugging into the calculator. Plugging these values into the equation is not that bad. It's plugging them into the calculator that takes a little bit of time. So I'm going to show you one example, and it's one example that kind of does it 2 ways. So we have this situation going on here with Kimberly, and I'm actually only going to do part B. So we have Kimberly, and her family invested in a certificate of deposit, a CD, when she was born. A lot of people do this. and the amount that they deposited was $3,000. And the amount of interest that she's getting is 8%. Now for B, what it wants to know is what will the value, or will the value of Kimberly's CD, this certificate of deposit, be better after 18 years, so there's the time, if it was compounded annually rather than compounded quarterly. So we're going to calculate this compounded annually, and we're going to calculate this compounded quarterly, and I can spell quarterly this time. So the initial amount that they are depositing is $3,000. So that will not change for either one of these. The only thing that's going to change is the N, the number of times that it's being compounded. So the number of times it's being compounded, if it's annually, that means it only gets compounded once. If it's compounded quarterly, that means it's compounded 4 times every 3 months. So that's the only thing that changes between these two. The equation will remain exactly the same except for the N value. So that equation again is up here, and you may want to write this down so you have this handy. So we're going to plug into this equation, and it's not really close. I can try to zoom out a little bit so we can have it. It's not going to work. So if it's annually, let's write that formula first. We have A equals, and then it says P, which stands for principal, or the initial amount. We initially deposited $3,000, so 3,000. And then we have 1 plus the rate over N. So the rate is 8%. So you're not doing 1 plus the rate. Now this one just wants the rate. 8% as a decimal, 1, 2, is 0.08. Over, now remember, this one is going to be the exact same thing at this point. 3,000, 1 plus 0.08 over. Now, it's over N. This one has an N of 1. This one has an N of 4. And then it's raised to the N times T power. So our time for these are 18. So if I do 1 times 18, this one's going to be raised to the 18th power. For this one, if I do 4 times 18, 4 times 18 is 72. So this one's obviously, you're raising it to a larger exponent, so that, I'm thinking this one's going to be worth more just because it's raised to a higher exponent. So let's take a look and I want to show you how to plug this in. Turn that. There we go. Okay. So to plug this in, we are going to do, okay, there we go. 3,000 parenthesis 1 plus 0.08 divided 1, get out of the parentheses, and then the A to the B, 18. So see how it's kind of nice? It sets it up really nicely in your calculator. So if it's compounded annually, after 18 years, Kimberly will have $11,988.06 in her account. So that's it if she's earning 8% compounded annually. So now if she does quarterly, now the only thing, this is the best part about decimals as well, the only thing that changes is this 4 and the 72. So I'm going to get rid of the 18, make that a 72, get rid of the 1, make it a 4, and there's my answer. So if it's compounded quarterly, she's making $12,483.42. So obviously it makes more sense if we can compound quarterly versus annually. The junky part sometimes with money and these certificates of deposits is that you don't really get to choose how it is compounded. So today, your assignment is pretty short. I do want you to make sure that you are paying really close attention to the directions and plug into the equations correctly. I think you have 5, 6, 7 problems, that's it. And most of them use actually this formula right here. So any questions, please reach out. You will be using these formulas next week during your full virtual time.